棒のトマト、棒のトマト、棒の棒のトマト、赤上げて緑下げてトマトマトマト。All things fall at the same rate. No, they don't.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that?
Here is a feather and a hammer, and when there's air inside the tube, have a guess what wins? The hammer, of course. In that last experiment, the hammer won by a country mile. So what we're going to do now is try something slightly different. We're going to remove all the air from the tube inside to give us more moon-like conditions. Welcome to space. Okay, so we shall now try the experiment again. So last time the hammer won, hopefully things will be slightly different this time. So what we saw in that experiment was that all objects fall at the same speed. The reason this was the case was because we removed all air resistance in the tube.
Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
So we're going to be dropping several things off of a tall building today. The first objects we're going to drop will be the two basketballs of different sizes. And you can see them up there in the window of our insectary here. And on my signal, they're going to drop them. Ready? Drop. And what you saw there was that the balls came down at different positions. Part of that was due to being released at slightly different times. And we can correct for that when we analyze the motion a little bit later. The next objects we're going to drop will be the lacrosse ball and the lighter wiffle ball. We'll just wait for the traffic to clear and the wind to die down. Ron, ready? Let it go now. Well, as you can see, they came down at markedly different rates, and we'll see this again and again in the different kinds of objects that we drop. The next objects that we'll drop will be the golf ball and the small wiffle ball. Ready, Ron? Drop now. As you've seen, the two balls come down at markedly different speeds, and we'll have to analyze this more carefully to see if size makes a difference, but you see the point consistently. Heavier balls do actually fall faster than the lighter balls as long as they're the same diameter. The next object that we're going to drop will be a large watermelon and a small watermelon. Okay guys, get ready. Ready, drop, on cue. Now that had a rather spectacular end, but again you saw that they came down at different speeds. Again, we'll have to analyze it much more closely to be able to parcel out what's going on, but they did come down at different speeds. Okay, the next object that we're going to drop will be a large watermelon and a lemon. Okay guys, ready, ready, drop. That was interesting. It looks like the lemon actually came down faster. Okay, and finally the object will be dropped will be a large watermelon and a small cherry tomato, and we hope we'll be able to see the cherry tomato. Okay guys, you ready? Ready, ready, drop. And again, quite a spectacular difference of velocity. Here's very clear experimental evidence that indeed bodies that are different in size and maybe mass do actually fall at different rates. Here's very clear experimental evidence that indeed bodies that are different in size and maybe mass do actually fall at different rates.
Simultaneously. Taking a frame from our video clip, we can see this clearly and quantify the lag. The small basketball was dropped about 7 frames, about 234 milliseconds later than the big basketball. As we watch the balls fall, we freeze the frames as they fly past several landmarks on the building, and then on impact. We calculate the time of flight at each step and correct for the lag. At each freeze frame, we've overlaid the corrected times of flight. Let's watch this video again. You can see the flight of the two balls is very similar, but not quite. Specifically, the small basketball falls a little faster, about 67 milliseconds faster to be precise, than the large basketball does. What about the lacrosse and wiffle balls? Here, both balls were released simultaneously, but there was another complication as the wiffle ball hit an air conditioner on the way down. Thank heavens it wasn't a watermelon. For the frames we were able to capture time of flight data, the results are pretty clear. The light wiffle ball falls at a measurably slower speed than the heavier lacrosse ball. And now for the golf ball and practice golf ball. There was a slight lag in release time, but when we correct for that and measure the time of flight, we again see that the light practice ball falls considerably slower than the golf ball. I think we're beginning to see a pattern here. Now on to the fruit. Here, we're going to be dropping objects that have similar density but different diameters. Large watermelon versus small watermelon, lemon, and cherry tomato. First, let's see what happens with the watermelons. Again, there was a slight delay in releasing the small melon, but correcting for that, we see a result satisfyingly close to what Galileo said we should find. Despite one weighing about half the other, there is virtually no difference in time of flight. What about the melon and the lemon? Here we see something very interesting. The lemon initially falls faster, but during the latter part of the flight, the larger melon catches up to it and both hit the ground at the same time. Very interesting indeed. And finally, what happens with the melon and the smaller cherry tomato? Here the results are clearer. The larger watermelon falls consistently faster, so the tomato hits the ground about 100 milliseconds later than the melon. So there are some interesting results here, certainly more varied than the simple idea that bodies always fall at the same rate, no matter what their mass or density. This doesn't mean that Galileo was wrong, of course, just that, to paraphrase Desi Arnaz, we've got some splaining to do.
Drop! Oh, there they go, there they go! Oh! And the pillow still floats! Oh, that's taking ages. I think I won that round there.
The cooker goes off like a hare, whilst the tortoise-like pillow follows leisurely in its wake.
It doesn't matter, they're the same shape, so they're going to hit the ground at exactly the same time, I reckon.
Let it drop!
Well, all right.
Here's very clear experimental evidence that indeed bodies that are different in size and maybe mass do actually fall at different rates.
Hey, come here! C'est la tomato!